Oh, okay, there we go. 8.4, logarithmic and exponential equations. Okay, the reason why we study logarithms is because they are the inverses of exponentials. Okay, so if you take a value to the power of x, the opposite operation is taking the logarithm. That gets the exponent variable out of the exponent position. Okay, it undoes it. So opposite operations like multiplication, opposite is division. Opposite of addition is subtraction, stuff like that. So the opposite of taking x to an exponent like that, like x as an exponent, is applying the logarithm. And so this is sort of the big deal. This is where exponential equations and logarithmic equations, that's where they kind of meet here. So obviously a logarithmic equation, as you see in your book here, is an equation containing the logarithm of a variable. So you see in this one here we have x as a variable. That's considered a logarithmic equation. Now, when we talk about exponential equations, if you look here, this is an exponential equation. Why? Because the x is in the exponent position. Okay. What I'm going to show you today is how to solve an exponential equation a different way, and that is using logarithms. So right here, this is what I'm going to get to here today. Okay. This is what you have done so far in solving exponential equations. Now I'm going to show you how to use logarithms. See how logarithms show up here? Look at all that logarithm there. Okay. It's going to be super easy. Okay. I'm going to come back to that. But let's just get back to our notes here. Where are you? Oh, right here. Okay. So if we skip down to 8.4 here, okay. So this is what we've known to do. 4 to the power of x equals 2 squared. Okay. Now this is super easy. What we do is we have in the past here said that the best way to do this is to get the same base, right, on both sides of the equation. So you have 4 can actually be written as 2 squared. You apply your exponent laws there, and you have 2 to the power of 2x equals 2 squared. Once we get the same base, then you let the exponents equal each other, and you can solve. That's what we've been doing. We're going to come up with more complicated exponential equations, and exponential equations where getting the same base on both sides is not really easy or possible, really. So we don't want to go that route. What we want to do is we want to use a logarithm. So let's do the same equation over here as a second sort of example, second method. And what we're going to do is this right here. We are going to take the logarithm of both sides. So it's like an operation. When we're solving equations, we can add something to both sides as long as it's the same thing. Or we can divide something, both sides by the same thing. You can do that in an equation. And taking the logarithm or applying the logarithm to an equation works as well, just like that. So what I'm going to do is I'm going to do this. I am going to take the logarithm of 4 to the power of x. And I'm going to take the logarithm of 3 squared. Okay? Oh, actually this is a different equation. We can use the same. Sorry, did you write down 3 already? I kind of intended that to be the same so we get the same answer. Sorry, just change that to a 2. My apologies. Just change that to a 2. So we have 4 to the x equals 2 squared, okay? So we're going to do the same thing using the logarithm. All right, now if we use our laws of logarithms, what was the power law? What did the power law state? Because now we have a logarithm here, right? And we have a logarithm here. So what did the power law state? Remember that? Okay, same thing as multiplying it. Yeah, and it is the exponent, right? So this exponent can be brought down as a coefficient in front, can be brought down as a multiplier, and it'll be the same. So this is a rule. This is a law that works, okay, every time. So that's an established law. You can actually bring that x down. Now, that is the whole point of logarithms. This is why we love logarithms, or why I love logarithms, and why you most likely will love logarithms very shortly, is because this x up here, you can't do normal operations with it. But when it's down here, okay, as a kind of a multiplier, then it's easy. And so This 2 can come down. You can just write this as 4 as well, but let's just be consistent. Let's just show that this is happening. Okay? And now, log of 4 is a term all by itself, and x is a separate term, and they're multiplied. So I can divide both sides by the logarithm of 4. See that? And that cancels out, and I'm left with x equals over here. See, solving for x. Now, please be careful with this. All right. Couple things. Okay, you can't divide these two and simplify to 1 over 2. Don't do that. Also, please don't look at this as a number, a multiplier there, and then reduce it with this. Okay, those two, you cannot do that. That's not the same. That's a regular 2. This is part of a logarithm, so those, you can't do that. What else can't you do? Oh yeah, don't do this. Oh, hey, log. Let's just divide that out. Can't do that. Okay, because 22 over 4 is not the same as, or 2 times 2. That's not the same. So you can't do that either. All right. Remember, these are attached like sine and cos and tan. They're not separate. They have to be attached to a number. Okay, so now you just get on your calculator and you would evaluate that. So when you evaluate this on your calculator, 2 log 2 divided by log of 4 equals 1. And so x equals 1. Same as we got over here. Which makes sense, right? 4 to the power of 1 equals 2 squared. So that's a very simple example that we've used the 2 ways. Like bases on either side, and now using logarithms. So let's pop back to the example in the textbook here now. Okay, let's take a look at this. Just give me a moment to put this out. All right. And I'm going to take this right here, the 2 methods, and I'm going to go over this here with you. Okay. Save this one for next. Okay. Yeah, did you see that up there? This right here? Yeah, do you know why I had to do that? Because people were not writing it properly. People were writing like the 4 as like as a base or something. You got to make sure you remember that the base is written down here as a subscript, exponent is written up here as a superscript, and this is just your number log of 4. Yeah, that's why I had to do that. Not you guys, but the last class, Not as good as you guys, of course. No. Okay, so so let's just briefly go through the first method. You don't have to write this down, just watch. Okay, we have something that looks like this: 2 times 25 to the power of x plus 1 equals 250. We're trying to solve for x. So in method number 1, we would divide both sides by 2 first, because that's just a factor. And so that's where they get 25 to the power of x plus 1 equals 125. And then they wrote 25 and 125 as the same base. Did this method. Solved a simple algebraic equation for x to be 0.5. If we pop over here, okay, this first step can be the same. Probably would be best just to do that. So you have just your power and another number or another power. Now, look what happened. They took the logarithm of both sides. Okay, so what does that do? Well, that allows this as an exponent to come down as a multiplier. All right? And what you have to remember is that x plus 1 is a binomial, and it's multiplied by 1 term. So that means, really, if you're going to multiply that out, it distributes. You see? So you get x log 25 plus log 25. Okay? So this is where it, you want to get x all by itself, so you eventually have to solve for x. And so you split the logs up here. Now we're going to subtract this log of 25 off. That's where it goes over there. You're going to divide by log of 25, both sides. Okay? And they use some rules here, which, yeah, okay, they see that. 125 minus log of 25, and they show that as a division. You can just get on your calculator and get 1/2. Okay? But a couple things I just wanted to point out to you from this example is that if you have a binomial here, you have to distribute that. Okay? That's important. All right? So again, this is in your textbook. I'm going to do one right here with you. Okay? And let's see. Don't want to do that one. What example is this one? Okay, so we're going to change our example here. This is a good example here to do, similar to the one we just did. Now, obviously, we have a base of 4 and a base of 3 here. Those can't be written in the same base, obviously, very easily. So we're not going to do the same base thing. We're going to apply the logarithm. All right, so you'd write this as logarithm of 4 to the power of 2x minus 1 equals the logarithm of 3 to the power of x plus 2. Now this is particularly tricky because we have x in two different spots. So this is why applying the log is going to be important, because we need to get this exponent down out of the exponent position. So we'll write this as 2x minus 1 times the logarithm of 4. And over on the other side, it's x plus 2 times the logarithm of 3. So we've successfully brought the x term out of the exponent position. If we do some distribution, just like the other example says there, okay, little expansion, you get this as your second line of work here. And now we're getting x here in that term and x in this term. Okay, so they're coming close to each other. And what we'll want to do is we'll want to get those x terms on the same side of the equation so that we can factor the x out. So it's going to look like this. 2x log 4 minus x log 3. We just bring this whole thing over to the other side. And this right here is going to go to the other side, which is going to become a positive. So log 4 plus 2 log 3. Okay, so now this x can come out. Factor an x out, and that's how we can get x all by itself in one spot. And you're left with 2 log 4 minus log 3. And rewrite the other side, and you can, if you want to save some time here. This 2, right, could also be written as an exponent up here. So you could write this as log 9. That's 3 squared. Okay. Okay, so now to get x all by itself, we divide both sides by this expression. And yes, you can make this right here an exponent up there, no problem. And then basically your calculator can take over. So you can write this as a single logarithm here, actually, can't you? Right? Log of 4 plus log of 9. What's that written as a single logarithm? Remember your laws? What's that? Okay, so what is it? Log of 36. Very good. And down here then, this subtraction is like a division, right? So that as a single logarithm, you have to put a couple things together. That 2 is going to be an exponent here. So it's going to be log of 16 over 3. Okay, everyone see that? And so on your calculator, you can just do that on your calculator to get a decimal answer. That's fine. Log of 36 is this number, and you can divide that by log of 16 divided by 3 to get the answer of approximately 2.14. Okay, so try this one on your own here, and I'm just going to freeze the screen here and show you the answer in a few seconds. All right, so if you take the log of both sides, you get this expression right here. This can come down as a multiplier in front of the log of 5. Multiply that out.